Hi, I'm John Sheehan.
And this is Payman.
And today we're going to talk about Project Centennial. When we started Windows 8, we came up with a new app model, and we call it the Universal Windows App Platform. And when we basically brought that to the world, people realized that we had sort of left them behind. So there's basically 16 million .NET and Win32 apps in the world, and none of them right now can come to the store, and they can't deploy to phone or Xbox or anywhere else. And so with the upcoming Redstone release of Windows 10, we are going to bring a new feature called Project Centennial. And basically, so basically, what is Project Centennial? Project Centennial is a way for you to take your existing .NET apps and run it through a converter and turn it into a universal Windows app. Now, when I say it's a universal Windows app, it doesn't mean that it can run on phone or on Xbox yet, but it does mean that you can put it to the store and sell it in the store and get all the benefits of deployment and servicing. So, so let's talk a little bit about how it works. So you have your existing Windows installer, and it goes ahead. It's using MSI technology or some other setup technology, and when you run the installer, it goes and it edits the operating system. So it puts files, in program files and System32, and it puts stuff all over the registry. And what ends up happening is the app becomes part of the operating system at that point. And because of that, you have issues like the operating system gets slower, the system boots slower, you can't uninstall the app. Sometimes one app will break another app. So there's a lot of issues that you can run into. And so what we're trying to do is stop modifying the operating system and instead just have the app be a separate state-separated component. And so what we do is we give you a tool called the converter. And what the converter does is it can record all of the changes that your installer would make to an operating system, and it can package it up and put it into an AppX file. And that AppX file then can be sent to the store and can be deployed out to anyone that's running the Windows 10 Anniversary Edition. So rather than talk about how it works yet, we first want to show you something. So let's go through to the demo.
All right. So I have my converter all set up with this string. I'm going to go ahead and run it. And John, you can explain what's happening.
Okay. So what we're doing here is we're taking a real app called Slack. Now, probably a lot of you use Slack. It's a great way to collaborate. And so we've taken their installer, and we're going, and live on stage right now, we're going to convert it into a Centennial app. And so what's happening right now is we are spinning up what is called a Docker container. And so it's basically a clean instance of the operating system. So if you think about the laptop that's running here, it probably has a bunch of extra software installed. Can you make the font bigger? Bunch of extra software installed and all those things that likely will not be on the end user's machine that you deploy to once you go to the store. And so we go ahead and spin up an image of Windows that's pristine. It's just the bits that come from the operating system. And then inside of there, we run the installer. And that installer goes and it actually runs, which is the reason that we're not tied to any particular installation technology. So it'll go, it'll put files in program files or System32, or it'll put them wherever. And then once those files are laid down, the operating system will go and edit the edit the registry, and basically make a whole bunch of changes to the system. But what's happening is it's not really editing the local system. It's running in this little Docker container that we have. And so there's basically file system filters and there's kernel registry filters that are capturing all the changes that the installer makes. And then when it's done, we package all of that up and we put it into an AppX file. And as part of building that AppX file, we actually go and create the AppX manifest for you. So it does things like it creates a tile for you. It'll go and figure out what file type associations that your installer laid down. It basically analyzes all the information and it generates a package. And now you can take that package and you can deploy it to a Windows 10 Anniversary Edition OS, and that will deploy and you can run it. So as you can see, it takes a little while to do this because we're really running the installer. And so we're not doing any sort of analysis of like an MSI file. We really just run it. And so once that's done, we can throw away that image, and so your operating system stays clean. And the next thing you're going to do is basically take that AppX file and you're going to test it, because in some cases you basically can't, like your app might not work in Centennial. Might not work in Centennial for various reasons. Like, for example, if you have a kernel driver, we don't want apps coming from the store deploying kernel drivers, for security reasons. And same thing for a like NT service. So we have some basic rules about Centennial apps. First, they need to run as the user. So they can't like run as NT or as local system. They can't run on the kernel. And secondly, they can't do things like inject themselves into other processes. So we're really talking about apps here. We're talking about taking something that the user launches and runs and either consumes or creates content or whatever, and when they're done, they output something else, not going and modifying the behavior of the system. And by the way, we're going to try to go quickly through this because a lot of you have probably already seen some of the other presentations on this, and so we really want to get to the question section. There's always a lag from when you submit a question and then it comes through the system, and so we can answer it. So please start submitting your questions right now, and we can go and answer them at the end. So
it finished now. I'm gonna try signing it, and once that's done, we can go ahead and deploy it.
Okay, yeah. So all AppX files need to be signed in order to deploy it, and they need to be signed with the cert that's trusted for code execution on the system. And that's really just to make sure that this mechanism doesn't get used to deploy malware or something else that's not trusted on the system.
So now this is the folder that it created the AppX in. I can double click on it, click on install.
And so as you see, he's using the new app installer feature that we have in Centennial Edition, in Anniversary Edition. And so it lets you double click on any AppX that's signed correctly and it'll install.
And there's our app. I can log in, create a new team, all that stuff.
Okay. So this is a fully functional version of Slack, and we didn't require any code changes to do it. And as a matter of fact, we're obviously not the Slack team, right? So Slack's a separate company, and we've been working with them, and we hope that they will eventually want to bring Slack to the store. And if they do, as you can see, it's going to be a very simple process. All right, so let's go through and just talk about the process in a little bit more detail. So you start with your original code base, and basically it's the one that you've been building for years. It probably runs on Windows 7, so you sort of have this long history of code from your application. And we want to make sure that your code base continues to run on older versions of Windows, like Windows 7 or Windows 8. And so basically, this is why we go through this analysis process. Because what we want to figure out is, where does your code expect all the resources to be? Excuse me. For example, lots of applications put files outside of their install directory. So they'll put a DLL in system32, or maybe under program files, common files. And the code just naturally expects those files to be there. And the same thing with the registry. Your installer probably puts stuff under HKLM, software, company name, app name, or whatever. And when your code runs, it does reg open key and expects to see those keys in those locations. And if we in Centennial didn't preserve that behavior for you, then your code would break. And so we try to make sure that your code's going to keep working, but we have this problem, which is we don't want to take the files and registry of the local system, and we don't want to pollute it with parts of your app, right? So if we actually went in and wrote everything into the registry and wrote everything into the real file locations, well, we'd be right back to having the same problems that we were trying to solve with Centennial. So we just don't do that. What we do instead is when we create this package, we record all the information of where the files are supposed to appear to be and where the registry keys are supposed to appear to be. And we use the same file system and registry kernel filters that we have to have your app understand, or sorry, not have your app understand, have your app successfully be able to use those paths. So if your app says, you know, load library C:\Windows system32 mydll.dll, it will turn around and we will redirect it in the kernel to the location that's actually your install directory. And so your code doesn't have to change. And it's one of the big reasons that we do that. There's one other thing that we do, is that we make sure that if you go and try to edit the registry or you try to edit the app data folder, we redirect those to a separate location. And the reason that we're doing it is called state separation. One of the reasons that there's no such thing as a safe uninstaller is that all the files and registry entries on Windows are not in any way tied to any particular application. And so, you know, in the old world, once those things are put on disk, there's really no way to tell A, who has access, or sorry, who has a dependency on any of those files, or B, for any edits that happen on runtime, which app actually made the edits. So what we do is when your app says it goes into the app data folder and say under app data local, and it creates a new file, we will redirect that file to a private location that's specific to your app. And that means if the user decides to want to install your app, either because they don't want to use it on that machine anymore, or because maybe it got corrupt in some way, they hit the uninstall button, we completely clean up. And now if they reinstall your app, now they'll start in a nice clean state. So you're starting with this app. This is the type of app that you're starting with. And then, so now you're going to run it through the converter as Payman just showed. And what the converter is going to do is, after it captures all that information and puts it in the appx file, now you get to deploy it. But on top of that, at runtime, we actually put it in what we call a Centennial container. And the Centennial container does a few great things for you. First of all, it gives you identity. So if you think about universal Windows apps, all of them have identities. And it's why they can use the APIs that basically assume identity. So for example, live tiles. When you go to write the code to create to update your live tile, you just basically type a line of code that says update my live tile to this. Now, you just say my live tile, and the system knows who you are. The system knows which tile is yours, so it knows which one to update. But if you're a Win32 app, you have no identity, and so you can't update the we have no way for that API to know what your live tile is. The moment that you go through the converter, when the app launches, you immediately get to be able to start calling all these APIs. And so you really become not just able to call the desktop SDK, you're also able to call most of the universal Windows SDK. And so what we're going to do now is we're going to take you a simple app, and we're going to take you through the process of conversion, and then later trying to get to other platforms like IoT or Xbox.
All right, so I have a simple project here which I already did convert and added it to my solution here. Now if this loads up.
Okay. So what Payman's going to show you is starting with the preview release 2 of Visual Studio 15. There are now they've now built a project to support Centennial applications.
Exactly. So here you can see I have my desktop app. It's just a simple WinForms C# app, which is a status updater. So I have a combo box, I give it my status, and it stores that status for me into the registry for me to retrieve it later. And the piece that I have here is what John was mentioning, the desktop to UWP packager project. And what it is, it's going to allow me to deploy and debug my Win32 code within Visual Studio. And it's very simple to set up. All you have to do is you got to pass it the package layout folder, which the converter is going to spit out for you. And once you do that, it's going to automatically update the Apex manifest and all that for you. So just to show you what this app is all about, it's very simple. I'm going to run it, and you will see my simple WinForms app, which has my status. I can update it. And then just to show you here, it is being deployed as an Apex. I can deploy it again and do all sorts of fun things with it. So next, John is going to talk about what else we can do with this app.
Okay, so we basically talk about Centennial as the Centennial bridge, and a lot of people don't quite understand what the bridge part means. They sort of think that, hey, I can run it through the converter, and then there, it's great. Now I have I can have an app, and I can, at that point I'm probably done. And I already see a bunch of questions starting to pop up that we'll answer at the end that are asking about, hey, can I deploy this on IoT? Can I deploy it on Xbox? And the answer is currently no. And the reason is that even though you're able to call the Universal Window SDK APIs, you're still calling lots of desktop APIs. And those desktop APIs don't exist on other platforms. So for example, anything that deals with an HWind, so if you have an MFC app or you have a WPF app, WPF is built on top of HWinds. And so it's just not, WPF just doesn't exist anywhere else. It doesn't exist on mobile. It doesn't exist on IoT. And so because of that, there's work for you to do to migrate your app from desktop to just using the Universal Windows SDK. And once you do that, and once you're done, then you can deploy to IoT, you can deploy to Xbox, you can deploy to other places. And it's actually not as hard as it sounds. We've done a lot of work to basically bring more and more of the API surface from both .NET and from Win32 into the Universal Windows SDK. And so that means that mostly what you're dealing with is converting your UI. So, so let's go through and talk that. Okay. So, so basically, let's start the process now. So Payman started with this app that was purely a WinForms app, just written in C#, and it's basically calling the registry. It's doing the kind of things that desktop apps do that aren't allowed for other on other platforms. And so now what Payman will show you is how do I take my app and first start leveraging the Universal Windows SDK, start calling these kind of APIs, like adding a live tile, just making my app feel more modern and more integrated into the modern Windows system. And so, why don't you go ahead and show that?
Sure. So here I have the same app, but with a few added lines for the live tiles. Let me just show you that. So yeah, you will see it's the same WinForms app, C#. I've just added these few lines of code, which is gonna grab my status, add the date and the time to it, and put it into the live tab. So I'm gonna show that to you. I can just run it. And here's my WinForms app. I'm gonna set it to busy. I will pin this here, and then you will see that it says busy. If I went and updated that again to available, you will see it's going to refresh there. Very simple, just a few lines of code that I added here. Now, next, John's going to talk about what else we can add to our project.
Okay. So that's pretty cool. This app, even though it was a Win32 app and as a, or sorry, it's a a desktop app, and as a desktop .NET app, it couldn't have a live tile. We just don't have the way to do that. But now, starting with converting it to Centennial, we can already start making it a very modern feeling application. But now I know lots of people, and I keep seeing the questions already popping up, are talking about great. I have better deployment, I can make it look a little more modern, but I want to get to other platforms. I want to get to mobile, I want to get to IoT, I want to get to Xbox. And in order to do that, you really do need to start moving your code actually into the Universal Windows environment and taking it out of the Centennial desktop environment. And so to do that, it's pretty straightforward for most people. The big challenge ends up being your UI. So if you have a WinForms or WPF app, you're going to need to take and move that to XAML. Luckily, WPF and XAML have a common lineage, so it's not that difficult to move the app. It's definitely a bunch of work. I don't want to say it's no work, but it's not too difficult. We have a lot of experience. We've taken a bunch of WPF apps and converted them to XAML over the last couple of years. And a lot of the concepts come through, and even a lot of the code ends up working the same or very similarly. And so the conversion process basically looks like the following. You currently have some desktop HWind based window. And on a window by window basis, what you can start to do is you can start to create XAML pages instead. The big challenge that you'll face is that those XAML pages run in a separate process. And so you'll have to do things like move pieces of logic over together. And then, if there's some stuff that's still, or some logic that's still living in the full trust desktop process, you'll have to communicate between the two of them. And so, an example that a lot of people run into that the first time they start to do this is they say, hey, I have my desktop app, but I really want to implement the share contract, or I want to implement the file picker contract. And so desktop apps just can't do that. But the moment that you convert it using Centennial, and now you're running as an app that's deployed through AppX and has identity, you can immediately start doing that. So you can go into Visual Studio and you can create a new universal component, and you can say, okay, great, this component implements the file picker contract, or it implements the share contract. And you can write all of that code and immediately start getting your modern XAML code into your application, even though you haven't converted all of it yet. And so the one thing to remember, though, is that code that you write, the code that's participating in those contracts, it runs in the app container. It's real universal Windows code. It's exactly the same code that you would write if you were starting with the Universal Windows app and wanted to support those contracts. And so because of that, if there's something that has to happen that's going to be running in your other process, your desktop process, you'll have to use a communication mechanism. And we've built one for you. It basically leverages the app service functionality that we already have in the platform, which basically allows a bidirectional connection-based message passing scheme. And so you can go ahead and do that. And so let's go ahead and take a look.
All right, let me bring this up. So as John was mentioning, this is the step that I'm adding the background task right now. I'm adding this piece for it to be able to communicate between my two pieces. I'm going to add the XAML UI later. So let me just show you how the background task is working in my project. There we go. So you will see I have this new project now. It says background task right there. And this is a task that can run in the background. If I close my desktop app, that thing is going to continue running in the background. And what it does is it takes my status updates and it actually stores it for me to retrieve it later. So this is where I implemented that. It's taking the status update and it's saving it. And what it does, it also communicates with the user by showing toasts. And the way I have it set up right now is it's going to get triggered every 15 minutes or so. And this is where I'm registering this background task in my desktop, in my Win32 app.
And this is exactly the same way that you would register that if you had just a regular UWI.
Exactly. So I'm going to go ahead and run this. Actually, I need to run it again. So I still have my old UI here, but what I can do is I can set that trigger myself, which I was talking about. If I hit that, you should be able to see a toast about my status and the date and the time. So again, if I go and update that again to available, once I hit that background task trigger, my toast is going to come up again. So John already talked about it a little bit about the XAML UI, so I'm just going to show that as well, unless you want to talk about the slide a little bit. Or
That's fine.
OK, I'll just show that. So here, I've added a brand new UWP piece, which is just my XAML UI. You can see it here. It says my UWP app. And I'm just going to go ahead and just run it so you'll see what this new XAML UI looks like. Then I'll point out some interesting things here. So there it is. I mean, it just looks like a modern app. I have the same status updates there. But the way it works is that this main page for my UWP piece, all it does is it just takes the entry from my combo box and it passes it along with my app service to the desktop part. So I'm not using any code in this piece. It's just the UI. And you will see that here, I can add a breakpoint, and this is where my status is getting updated. So I can go ahead. I need to attach my desktop piece so I can show you that breakpoint. There we go. So now, once I change my status here, you will see that I'm hitting this breakpoint, which is where it's receiving the connection and it's doing what it needs to. It's storing it into the registry, and whatever else I needed to do with it, it's still doing it in my desktop app. So next, John is going to talk about how we can actually go forward with our bridging.
All right. So what Payman just showed there was he wrote code. Well, first of all, he built a new UI. Right, so he did the UI, and that piece is now full universal Windows code. But he still had logic that needed to run in the desktop process because it was editing the registry and was basically had more privileged access to the system and was calling desktop APIs like the registry APIs that aren't supported in the universal Windows app. And so basically, what happened there was he had two processes at that point. He had the process that displayed the UI, and that breakpoint that he hit, that is actually in a separate process. It's in the full trust process. That process was running without any UI. And so it's a pretty common pattern we see as we're starting to migrate applications using Centennial to get to a Universal Windows app, which is there's business logic and there's UI. And sometimes the business logic is complicated and it has a lot of just dependencies on existing desktop APIs. And so we find that we tend to move the UI first and get the UI running in XAML and looking the way that we want to, and just leveraging the business logic running in an invisible process that's a desktop process. And then once we do that, really then it's the last step is to take that business logic and move it into the app container and make it truly universal. And as I said at the beginning, we're doing a lot of work right now to bring as much of the desktop API surface into Universal Windows apps. So, as much of the BCL we can bring in, we are, Win32, even some of the legacy COM objects that are part of the desktop SDK. We're trying to bring all of those in so that it's much, much easier for you to take your business logic and just move it into the app container. And so the final step that you have is once you get all of that code out of the desktop process and into the universal process that's running in the app container, now you're done. Like you can run that code on IoT, you can run it on Xbox or HoloLens or wherever, and you can continue to evolve that code and add features and everything. And so let's look at the final step of the process.
Great. So I'm going to close this one and open a new one. For this last part, all I've done is I've taken that code from my desktop app where it was storing the status into registry. Now it does application data. So it uses application data to store my status there. So I can just go ahead and delete my desktop app now. Now I should be able to just deploy this on my device here.
It takes a minute and do this. Oh, and there we go.
There we go. Oh, I actually think it did deploy. I just couldn't run it, but this is the app that I had. Basically, you can see it's the same thing. I can do all the same things here. And cool thing about it, if I close this, open it again, you will see that it saved my status there because it was doing it inside the container into application data. And that's the last step. We have it on the phone, and we're fully off the bridge.
All right, go back to the deck for me.
I think that's the last slide we have.
Is it? All right, so I just want to recap because we kind of went through that very quickly. Luckily, we were saving tons of time to answer questions because, if you really want to get the longer story, you can go on and look at the video that was recorded from the Build conference this year that has basically this content, but a lot more detail in it. But the key things that I just want to reiterate is there's typically very little work for you to take your apps from their existing desktop installation technology and then move them into Centennial and make them AppXs. And at that point, they're ready to go. Assuming that you tested and it works correctly, you can deploy it just through a double click from an AppX. And you can also go and try to, you can go submit it to the store and start selling it or deploying it to all your users through the Windows Store. A couple of things that I can already see questions start coming up as well is this is for apps right now. If the purpose of your app is to modify the system in some way, and it needs to modify the system in order to work correctly. For example, if it's trying to modify the system so some other app notices that it's there and then tries to do something. In our V1, we're not supporting that. But in the future, we are going to support those things. So we'll go off and we will make sure that we have a plugin model for Centennial, and also make sure that if your app has a plugin model and other apps tend to modify the system so you can see them, that will continue to work, and your apps can load plugins that are installed on the system. So let's go ahead and start going through some of the questions that we have here. So the first one is from Wendell. It says, how to get support for Centennial? I have an issue where the converter script is complaining that the directory paths are too long. I started to try to debug the script, but I assume someone has already run into this issue. And the answer is yes. We've already seen this issue. We already have it fixed internally, and hopefully it will be in the next release of the converter. All right. So the next question is, can VSTO add-ins be converted via Project Centennial? If so, how does it handle the uninstall? So no, right now in V1 you can't build an add-in that some other app's going to see, and it's pretty obvious because all the changes that you would make to the operating system so that VS would see your plugin, those get packaged up and they get put into a private area for you, and so when we deploy your app, Visual Studio wouldn't see your plugin, and so your plugin would never get loaded. But as I said at the end, we really do want to make sure that moving forward that we have a good solid support for plugins in Centennial, and really in UWA in general. We know that plugins are very powerful. Like being able to augment another app is very powerful. We've already started doing this. If you look at Edge. Edge extensions are just, Edge is a UWA, and it is just leveraging the standard UWA extension model. So for your UWAs, you can already do that, but we know that, just like with Centennial, and you have a large code base that is already doing things a certain way, we know that you want that to continue, and so we will work through that and come up, in a later release with a solid model for supporting Centennial plugins. All right, the next question is, since threads don't yet exist in UWP apps, how are they handled in Project Centennial? All right, well, there's two halves to that question, or there's actually a few pieces. First of all, threads do exist in UWP. Anytime you're using the thread pool, you're creating threads. The create thread API wasn't in the UWP API surface, but again, as I said, us bringing in lots more APIs, create thread is one of the APIs that we want to. Actually, we may have already brought in the anniversary edition of Windows 10. So create thread should be there soon. So that's for the UWA portion of it. For the desktop portion of it, obviously, lots of apps call create thread, and your app will continue to call create thread. There's nothing about the desktop process that restricts it just to UWA APIs. So hopefully that answers your question for you. Another question is, any news on support for SQL Server from UWP apps? I'm going to interpret that to say that the app wants to have access to a local SQL Server. We don't currently plan on supporting any app deploying SQL Server. We have had some discussions about, or we're working on things like allowing apps to leverage local things installed on the system. But as of right now, that's still a very difficult thing, because if you have a user who doesn't have SQL Server installed and they go and install your app's not going to work, and there's no way for your UWA to go and install SQL Server. So we've been talking about some of those things, but we don't currently have any news on that yet. Okay, we have a question from Mike. that says, when are large MSFT or Microsoft projects planning to adopt UWP, like Office? Well, Office already has. So if you go to the store right now, you will see Word, Excel, PowerPoint, OneNote. You will see lots of Office apps that are already leveraging UWP. Office has the same problem that a lot of you have, which is they have a very large code base that they have a huge investment in, and they need to support, down level to Windows 7 and Windows 8. But they have been for the past several years, working and moving more and more of their apps to supporting UWP, and therefore running on phone, and now and coming in soon running on Xbox. So they really have been adopting it. It's just that, just like everyone else, it takes some time. Okay, we have a question from Praveen. Is it possible to convert VC++ static library code to be converted to UWP and run on mobile? The Centennial conversion doesn't do anything to help with that. Right now, the stance that we have is that if you're going to consume or use the C runtime, you really should be using the dynamic versions of it. I haven't heard any workaround or any requests to get the statically linked one. It would be interesting to understand why static linking is important for an app, but we don't have any. I don't know of any changes being made on that part. Okay, we have a question from Josh. What is the intended path for console applications in Project C? I can't launch a C# console application installed with the Project C AppX from a command prompt, as access denied error is returned. We already do support it. The way that it works is we added a new extension point. I can't remember. Do you remember the name of the extension point? It's I'd have to go look it up. But basically, we allow you to define a short name for your app. Like, so let's say that your application is called foo. We let you say, hey, I want someone from the command line to be able to type foo.exe. And what we do is, when you register this short name, we, under the covers, we put it into a file in a location that can be found. And now, from the command line, if you type foo.exe from anywhere, the app will launch. So it is already supported today. That should already be in the preview release, but it does mean you need to go and register that short name. I assume what you were trying to do was use a command prompt to drill down to the path where the app is installed and trying to run it from there. That will not work, because we need to go through kind of a launch path so that we can set up the Centennial container. We can make sure that the registry filter's configured and the file system filter's configured. So we need to do more work than that. And what we didn't want to do was put that directly into create process, because that would potentially slow down every create process in the system. And so we use this mechanism of registering a short name for it to work. But it definitely works, and so you should be able to try it. If you can't figure out how to do it, just ask a question on our user voice forums. Wendell asks, when will the next version be released? I believe the next flight is imminent. And so we're, at this point in the Windows release cycle, we're releasing flights pretty fast. And so you should have a flight fairly soon. I would go and look at the blog, go and look at the Windows blog to find out exactly when it's going to be. Okay, we have another question on legacy .NET applications using C++ DLLs, MFC apps. Can we convert these types of apps to UWP? C++ is perfectly fine as long, and you can have tons of C++ DLLs as long as they are as long as they're calling APIs that are in the universal Windows SDK. It says MFC apps. We know specifically MFC is built on HWinds, and so HWinds just don't exist on other platforms. And so to be a true UWP, your code can't be leveraging HWinds. So any code that you had that was MFC, you would need to convert it to XAML. once you converted the UI to XAML, most of the rest of the stuff you should be able to just run. There's another question from Martin that says, what about old Delphi or FoxPro applications? Also, what if old application use SQL Server or local SQL Server file? So yes, I don't know if actually I think we have tried Delphi, and I think someone also tried FoxPro, surprisingly. We've also done stuff like VB6. We even took the VB6 app itself, the old developer UI, and we converted that to using Centennial, and we can even deploy that. So yes, all of those old apps can totally be converted and should work. As far as local SQL Server, if your Centennial process is running and there is a local SQL Server that was installed, it can definitely connect to it, and that should just work. The one caveat is your installation of your Centennial app itself can't deploy the SQL Server. So if it was an enterprise scenario, the enterprise could use SCCM to push out both the SQL Server instance and push out the Centennial app, and that would work. The interesting thing is SCCM will already support Centennial because Centennial is really just a UWP package, and so as long as the deployment technology supports UWP, it'll just work. We were even able internally when we built Centennial to start submitting stuff to our test store, and the store team didn't even know. Right? We were just able to support. We were able to submit stuff, and so it does leverage the existing deployment stack. So there you go. All right. Well, it looks like we don't have any other questions coming in. So with that, I'd like to thank you. And if you are looking to get, actually, can we switch back to the? Oh, it is there. So if you're looking to get more information, the main place to go is we have a short URL, which is aka.ms/desktopbridge.
That's it.
And the sample that was just, that payment just shown, will be posted online soon, so you can go and try the new Visual Studio project. You can go look at how the code changes were made and get those samples, and those will be there. And it looks like we had one more question come in, and so we'll answer that, and then we're done. Jeff asked, can VB script apps be converted? Can that old HTA app based on IE be converted? I don't know. I believe someone tried doing that, and the VB script itself, like if it's just a VB script file, there's no actual process there. There's no exe. We could probably try. You could probably try to, use one of the tools that lets you generate an exe to run scripts. But in general, like VB scripts aren't really apps. But HTA applications, I believe you could actually convert, but it would probably take some work. So I would probably ask that question on the user voice forum, and we can give it a try and get back to you. All right. Well, thank you very much.
Thank you, guys.